Today we are going to discuss lesson number 19, which is current electricity. So before going on to current electricity, first we'll look at what is static electricity. So we have discussed about static electricity when we were in grade 9, right? So when you were in grade 9, we discussed about static electricity. If you can remember that if you rub a piece of if you rub a plastic pen or a straw with a piece of cloth, and if you hold that rubbed pen or straw close to time with paper, you will notice that these little bits of paper will attract towards the rubbed pen or the straw. So that is because of the static electricity, right? So static electricity means it's not stable. It stays only for a very short period of time, right? So if you rub a plastic pen with a or a comb with your hair and bring it closer to tiny bits of paper or tiny bits of rigid foam, you will observe that these tiny pieces will attract towards the rubbed comb or the pen. So actually what is happening in this incident is, you know now that the atoms are comprised of neutrons, protons and electrons, right? So even the pen, comb or the plastic straw is also made out of atoms. So when you're rubbing, the protons and electrons are in the middle, that means in the nucleus, but the electrons move all over the around the nucleus, like our solar system. But the sun is in the middle and the planets move around it, right? So likewise, the electrons also move around the nucleus. So and now the electrons can be removed or the atoms can gain electrons. So when you are rubbing, what happens? Either the electrons in the pen or the electrons of the atoms which are in the pen or the straw will be removed, or they will gain electrons from the rubbing cloth or rubbing material, right? So if they lose electrons, what happens? They will be positively charged, right? So when you remove an electron, so then now the electrons are negatively charged. Now the negatively charged particles are lower than the positively charged particles, that are protons, right? Because the number of protons and electrons are same they are same in amount, right? So if there are 10 electrons in an atom, there will be 10 protons in that atom. So if they gain electrons, what will happen? The net negative charge will be high because you have additional negative charges than the positive charge. So in the static electricity, either electron gaining or electron removing will happen. So when some objects are rubbed, they acquire a force to attract little piece of paper, dust and other light particles. Such objects acquire this attractive power through the static electric charges generated by rubbing, right? So the reason behind this incident is the fact that I discussed earlier, the removal of gaining of electrons. So charges that are found stationary on an object. The charges that are found stationary on an object, they are not moving, right? Object in this manner are known as electrostatic charges, right? Charges which are found stationary, not moving. So in our normal current, the charges move. Actually, not the charges, the electrons move. But in this case, static means it's very temporary, and the charges don't move. So when such accumulated electrostatic charges begin to move, they give rise to an electric current, right? So in the static current, the charges are stationary, but if you allow these charges to move, what happens? An electric current will be generated. So there's a small example or an activity in the page number 142, activity 19.1. So you need a piece of PVC tube. You know what a PVC tube is? A piece of polythene, a neon bulb, conducting wires, and a stand. Right? So you need a PVC rod, neon bulb, connecting wires, polythene, a piece of polythene, and a stand. So you have the neon bulb like this, right? So you have the neon bulb like this, and you connect one of the ends of this neon bulbs to the rubbed PVC tube. So this PVC tube is rubbed with the polythene, right? So you connect this PVC tube with a wire to one of the ends of the neon bulb. The other end will be connected to the world, right? So you will notice that this neon bulb will light up, right? So this actually what happened here is the rubbed PVC tube contains electrostatic charges, and once you connect these rubbed or the PVC tube with static charges to another conductor through a conductor, you can generate a current because the charges from here will flow through this wire to the bulb, right? So then an electric current will be generated. The current of electric charges flowing through a conductor is known as an electric current. So, the current of electric charges flowing through a conductor is known as an electric current, right? So, we have the static charges and you connected it via conducting wires. So then what happened? The charges started to flow through the wires. Then what happened? An electric charge or not an electric charge, electric current was generated. So how this so you will have a problem how these conductors will uh, how these conductors can move these charges, right? So because here you know that the PVC tube is charged, but you don't know whether this conducting wires contains charges, right? So you may wonder that how these charges are carried through these conducting wires. So for that, we'll look at the inner structure of the conductors. So actually, conductors are normally composed of metallic ions. So conductors are copper, sodium, right? All the metals, right? Then what? Lead, right? Uh, Silver. So they are comprised of positive charges and negative charges. That those are electrons. So if you take a piece of sodium, right? Sodium is in the first group, right? You know it's 2, 8, 1. 11, no? The atomic number is 11. So it tends to remove this electron in order to get the noble gas configuration. So always they try to remove this electron. So if you take a pure piece of sodium, you will have only sodium, but the electron in the outer shell is always removed like this. So in each atom, the last electron, the electron in the last shell is removed like this. So they are in like so now the sodium ions are like this, and there are corresponding electrons. So we explain this theory as this in a conductor, the conducting atoms or the metallic atoms, metallic ions are zinc. I mean they are in a pool of electrons. Pool of electrons. Right? So electrons are the electrons make the pool, and inside that ions are there. So when you connect a charge, will take the charge PVC tube, what happens? The charges are high in this PVC tube, right? Because you have, generated charges by rubbing it. So the charges mean the electrons. Either they can gain electrons or they can remove electrons, right? So what happens? So charges are high in this piece of PVC tube, but we'll say that this is the conducting wires, but we don't take sodium because sodium is a solid, right? We normally use copper or silver is a little bit expensive. Silver is the best conducting material. So we will change it to copper, right? Otherwise, because I took sodium, you can to explain this, right? Because you don't know much about copper, right? So copper. So actually copper 2 plus. So what happens? The electrons move from here to here, right? So electrons are going through this. So they come to this position. So these electrons will also vibrate and they will tend to move towards that side, where the electron density is low. So that's why that's how these stored charges are carried to the conductors. So we call these electrons as free electrons. They're free electrons. They can move anywhere, right? So when these electrons come, they tend to vibrate and they tend to move because this electron density becomes very high when these electrons also comes here. So they try to reduce that density by moving towards the lower density side. So actually this happens in the normal battery also. So if you take a battery